So I will enhance my vacation here to set it from, I will go away the whole September. Actually, I've deserved it after this presentation. I will save my draft, and as you can see, it's now activated, my new vacation. And yeah, that's one thing I wanted to show you, right? We are on the new DB driver here, and you cannot tell the difference. And this is a good thing. So let me show you the analytics list page here in S-Flight, which showcases some advanced OData analytic queries. You can see on the left-hand side what here is fired against the server. So let's just click around a little bit, check out the new bookings of this one airline. And as you can see, everything is there. We can go into the details as well, check out everything, what's going on here. And yeah, that's already it. This is how simple it is to integrate a new CUP.js into your application. I'm very sorry, I have a little sore throat. But nevertheless, I want to show you now how you can add Postgres to your application, right? So let's first go again into our CDS environment and check out what the default production environment for our database looks like. As you can see, the implementation points to our HANA service, which is still the default here. We want to change that now. It is, again, as simple as typing npm add CUP.js Postgres. So, wait a little bit. So as you can see, the Postgres adapter has been added to our dependencies here. I can check out our new production environment here. The plugin mechanism will again take care. This is now the new default. Here, what you can see is also I have added a vcap service with my credentials for a Docker container, which I'm about to start in a minute. And you can see the implementation pointer now doesn't point at the HANA service anymore, but at our new Postgres adapter. So now I have to obviously fire up the Docker container. This is the same thing Daniel showed in the keynote this morning. But for me, it's working at the first try. So let's do it. It works. So now we are already at the point where we can start our application with our default profile PG. Do this. So again, we are at the landing page here, and we go into the list page, and whoops, yeah, obviously we have an error. Somebody know what might be the reason of this error? Maybe Simon? All right. All right. There is actually no schema deployed. This is true. Yeah. And now we're gonna have to stop the server again, and I will show you how easy it is to deploy your CSV data to Postgres as well. It's all right. So it is as easy as saying CDS deploy to the PG profile. It will again take the default environment credentials and deploy the CSV data to my database. Done. Easy. I can now go again and hit PDS watch, start the server all over again. And I can go to the list page, do all kinds of fancy scrolling. Maybe I will this time edit my sightseeing trip to New York. I recently have been there. It's beautiful. I'm excited. I will add the Statue of Liberty here. So as you can see, the draft orchestration works as well in here. And the cool thing is you don't even notice that we are running a different database here, right? It's with the first demo. So we go back to the analytics list page. Same thing here. We have the possibility to fire advanced OData aggregation queries against our data here and get some nice UI stuff in here as well, right? We can click around, do things, fire queries. So this was actually the first part of my demo. Somebody have a tissue for me, maybe? So this was the first part of my demo. It should illustrate how easy it is to integrate the new database services into your application. Give me a second. Very sorry. Okay, let's go to the next part. I want to show you the advanced capabilities which come with the new DB services as well, because we do not only have feature parity between the old CapJS SQLite stack and the new one. We obviously enhance the feature set a lot to enhance your developer experience even further. So let's go over to my next demo in the upper side, in the upper half of my screen. You can see a CapJS notebook, a Cap notebook, right? I just use it for writing down queries. I'm going to show you now for better readability. And in the lower section of my screen, you can see me typing in the actual queries in the CDS REPL environment, which gives me easy access to all kinds of CDS APIs. So let's go. Actually, you can see I'm in the Cloud Cap Samples repository here, because my target is to fire some queries against the bookshop, because we all know it, and it gives us some nice illustrations here. So I have already set up my CDS environment to use the new CapJS SQLite. To use the new CapJS SQLite service. And now I'm already at the point where I can start my CDS REPL. It will automatically take the default environment here, which is now SQLite. I will showcase you everything I show you now with SQLite will also work with Postgres. I promise it to you. So the first thing I want to do here is I want to start an interactive session with my bookshop. So I need to bootstrap it. It's done. Deployed all the data in our CSV files. It's the original sample. The next thing I want to do is I want to make use of the CDS Reflect API for easier access to the underlying entities, right? I don't want to say select from sap.caphire bookshop.books. I just want to say select from books, and this is what the Reflect API now does for me, right? I do not have to type the fully qualified name all over again. So now we're all set. We can jump into the first feature, and I'm excited to show it to you. It is the support for path expressions, right? And just take a minute and check out this query here. We have select from books, right? We want the title of the books, and we want for each book, we want also the author name and the genre name. For us humans, it's quite understandable what we are trying to achieve here, but for a SQL engine, obviously it doesn't know what to do with an author or with a genre name, right? Because it's in a different table. So what you have had to do in the past to make such a query work with the old SQLite implementation was you had to write all the joins by yourself. And this is not the case anymore. You can just use those path expression just like you are used to do in your static views, right? So let's first check out the Cap CQN, how I call it, the Cap style CQN, which is super comprehensive and understandable. Again, you can see nothing really fancy going on in here. We just have our simple columns with the path expressions in. So, and before we can now render some SQL into SQLite or Postgres or HANA, we first have to normalize this Cap CQN query, right? And this is one of the core mechanisms of the new DB service architecture. We are now able to normalize such queries in a way that any SQL dialect can understand what's going on there. I mean, just be able to render what's coming out of the normalized query. So I will now show you how the normalized query would look like for this. And the first thing which comes to my eye here is the extensive from clause, right? We have multiple join nodes in here. We have obviously joined our author with the books and also joined the genre with our books, and provided the correct relations in the on condition, obviously. And we have the correct table aliases put into the columns for you. So now this is, the normalized query here in CQN. It's not really good readable. That's why I'm going to show you the SQLite string, which comes out at the end from your original cup style query. And take a moment, look at it while I'm coughing. I'm sorry. So we have 3 columns in here. We have 2 join nodes. Each has a dedicated alias. And we access the alias through those join nodes in here, right? So you can see we did all the magic for you here. Let me go over to the next feature, but the path expressions, they will basically be all over the place in the next samples as well, right? Now I want to show you the usage of the exists predicate. I really like it to narrow down the scope of my queries. So the first thing I'm going to do here is I will insert a new alpha into our database, which has not yet written any books, right? I've done that now. You can forget about it at the moment. I will come back to this later. Let's check out the next query first. We do a select from authors, right? We want to have the name of the author, and we want to count all the books the author has written. And the important part here is, what I want to show you is the where exists books clause in the end here. It says, okay, only give me authors which have written at least 1 book, right? And then we obviously have to group by the author name to make the count aggregation work. So if, again, show you the cupcqn query, it is really comprehensive and good understandable for me as a human being. Nothing fancy in there. So obviously, a SQL engine won't understand that. That's why we have to normalize it. I will show you the normalized version for this query right now. It is quite extensive. Let's go first to the from clause, which has grown from select from authors to select from authors left join books, because as you might notice in the count function, we navigated through too many association books to access the IDs of all books the author has written, and we need to provide the correct join condition for SQL to know which books belong to this author. So that's why the from clause has grown quite a lot. We can ignore the columns for now, nothing has changed there. And one exciting part here is the where exists subquery, how we call it, which comes out of this simple where exists book statement. Right, we get a subquery in here, and the subquery basically says, give me all the books for this author, right? And the exists predicate will make sure that this evaluates to true if the author, if the book subquery yields at least 1 result, okay? So, oh, I have forgotten to fire the queries against the database actually, right? So I'm so sorry. I will go back and to the first example real quick. Sorry for this mess, but I just have to put the weight in front of it and you can see the path expressions actually work. All right, so back to the exists example, right? I have shown you the normalized query. I want to show you the SQL, which comes out in the end as well. It's again now optimized for SQLite. And we go in here, put it in my editor, and you can see the SQLite query, the resulting. We have a left join in here for the books ID in the count argument, in the count function argument list. And we get a select, sub-select in our where exists clause. Right, obviously the aggregation is also there. So let's fire this query against the database so that you know that I'm not lying to you. It actually works. We get a list of all authors which have written at least 1 book, okay? And now just to illustrate why I have inserted this author, at the beginning I can prepend the not keyword in front of the exists predicate to get a list of all authors which have not yet written any book. That's it, right? So let's go to the next feature. It's the mapping for OData and SAP HANA functions. So we provide some easy mechanisms for you in the SQLite or in the Postgres layer, right? That you can have one function call in your cupcqn query, which then translates to the SQLite or Postgres compliant pendant of this function. So I will just simplify this a little bit. We do a select from authors here, and we want to calculate the average age. So we have the average function in here. This is actually an OData function. There is no such thing as average in SQLite. It's AVG. So we need to do the mapping somehow. And the years between function in here is a SAP HANA native function, right? So we do need to provide a mapping for you as well in here. So now, as you might know, or as you could guess, if we look at the cup style query, it's quite comprehensive. If we look at the normalized query, it has not changed a lot. We have prepended explicit table aliases in front of all references, but besides that, no mapping happened here because this is a generic SQL normalization, right? But now, if we want to render this to SQLite, we need to act, and I will show you how that looks like. It looks horrible. Oh my gosh. You don't want to write such a query by yourself. You know what I mean? Our query has grown so much in here, but it will work beautifully, right? So contributor of our new database services could go ahead, check out our repositories and contribute your own functions in here, right? And this has grown quite a lot. We have the mapping for the AVG, which one can understand, but all the other stuff in here is the mapping for the years between function, right? So crazy. And to prove that this works, I will fire the query against the database real quick and get the average author age back. I could go and enhance this example by getting the author age per genre back, which is an interesting statistic as well. So I have to navigate to the book's genre name, and then I need to do a $self group by $self.genre, right? This is how we called our column. And now we will get back a list of average author ages per genre. And the first one with the null rows, it corresponds to our upcoming author, right? Which has not yet assigned any date of death. Lucky for him. So let's go to the next exciting feature here. We have drastically improved the expand performance, but also, in my opinion, the debuggability for you. So this is all about nested projections. So here we do a select from authors. We want the author name, right? And we want to expand all their books. And for all their books, we want to expand the genre as well. This, in the old stack, resulted in 3 separate queries, one for the author, one for the books, and one for the genres, right? So we had 3 database round trips with the network overhead. But also we needed to match the books and the genre to the respective author. And for the genre, we had to find the corresponding books. And this we had to do in the JavaScript layer, which is blocking code for you all, and which greatly decreased performance compared to our no approach, which I will show you now. So let's go ahead, check out the cupcqn query, which is quite comprehensive, really easy to understand, in my opinion. We have a column with a nested expand in here. And yeah, now check out the normalized version of the query, where one part of the magic happens here. We want to have a look at this column here, right? The second column. This was our expand for the books. And what happens now is we build one correlated subquery for each expand in our query. So the first select you see here, it's this big one here. You can see, oh, it doesn't even fit on the screen. It's so bloated now, because this is what we do in the normalization. We do the heavy lifting for you. You just focus on your domain. I can scroll up. Gosh. But here you can see we do a select from books, and we correlate the list of books with their respective author. And within the book subquery, we do a select from genre and correlate the genre with the respective books, which we have correlated with the author before. So this is one thing we do here. But as you might know, if we do a select from authors and we have one column which says expand books and you get all the books for one author back, you might get several books back because one author might have written more than one book, right? So how SQL is not able to understand what's going on now because we are trying to squeeze multiple records into one column, right? So we needed to find a way to get rid of this problem. And we did so by heavily using the JSON functions in here, which are available in most databases. So let's check out the resulting SQLite string. And I will format it for you. It looks quite ugly, but I will explain it to you what's going on here. We have our main select, how I would call it, right, from the authors. And within it, we have a subselect for our books, which uses the JSON group array function because we are looking at a too many association here, right? Multiple books may come back. And what we do now is the database will execute a subquery with the correlation given. And what comes back is a list of books. And we pipe this into the JSON function, which will in turn transform this into one JSON object, which beautifully fits in one column, right? And we can do the serialization for you. So, and yeah, if you look within the subquery of the books, you find another JSON function, the JSON insert, which we use for 2-1 associations, because we know we only get at most one genre back for one book, right? So that's about it. This way, we can make sure that we sort of scalarize our results from the subqueries. And this greatly improves performance. I have to stress this once again. Let's fire this query. We get back a list of all our authors with a list of all their books, right? If we check out Edgar Allan Poe, he has written multiple books in here, and you can see we get back an array with a JSON structure in it, which you can now use in your application, right? This was it with the improved expand, and I have one more thing for you. It's the new options for selecting localized entities, right? So the first thing I'm going to do here is I'm going to insert a new Spanish translation for the Wuthering Heights books of Emily Bronte. So let's do this. I have inserted the new Spanish translation here. Now I'm going to set my default language to Spanish. I did that by using the CDS context locale. And the next thing, it is as simple as typing select.localized books, where ID equals 201, which is, you have to trust me, this book we just inserted to the translation of the book Wuthering Heights. So let's again check out the CUP-CQN here. It's a select from books, yeah, and it has this localized flag in here, which tells now the normalization function in between the or the normalization function for the generic SQL translation, that this here is a localized query, and we need to replace the refs in here with the localized versions if they are available. So if we look at the normalized query in here by hitting for SQL function, you can see one thing. Okay, we obviously expand the wildcard for you here. We have not given any columns, so we expand the wildcard. And the next thing which comes to my eye is we say not select from books, but select from localized books. So the next, and that's already it, right? And as you might notice, we do not use some convenience views for static languages like French or German or English anymore. We just select from the localized version, and under the hood, we will leverage the session context mechanism of, in this case, SQLite, to just tell SQLite, this is my default language. So if we access this one here, please use this as my default language. So if I fire this query now, I will get back the Spanish translation of Wuthering Heights. And that's already it from my side. I'm happy to hand over to my colleague Johannes now, who is showing you the architecture of the new state.
Sorry for the short delay. We have now switched laptops here locally. I will now show you a small intro slide. I promise it's the only slide. It's also not very fancy, but I roughly want to highlight that a class hierarchy that we have implemented within our new database services. We have a base database service, which basically covers all the things we require for any database, be it SQL or any other thing. We have a class for the SQL service, which takes all the heavy lifting that Patrice just showed you with the transformation of the CQN and converting it to SQL. It takes it from you, and the only thing that needs to be provided, how do I execute it later on the database itself. And then also, as shown by Patrice, we have the SQLite service and the Postgres service already released, which you already can use. And as also mentioned by Daniel in the keynote, the HANA service will follow soon. But we want to give this a bit more time because it's the one that most people use in production. So we want to make sure that it is rock solid or bulletproof. Then I'll quickly jump to VS Code because enough slides. Enlarge it a little bit. I have now opened the database service, and I don't want to go into detail for each tiny function, but I want to highlight the things that it provides. So one thing that a database service provides out of the box is a pooling mechanism, because it's a framework, you want to reuse your connections. So the pooling mechanism is built in. The only thing that needs to be provided by the actual database service is a mechanism how to instantiate connections or how to destroy connections. And this is the factory that you can see here. It must be overridden because, of course, the database service does not know the database drivers and their respective functions for this. Second thing that is worth mentioning is we have here the set function. The set function should serve as setting the as function to set the session context, also shown by Patrice. We have implemented session context also in SQLite, where it's not available natively, but of course in productive databases like Postgres or HANA, this is already there, where we can simply leverage it. Third thing that it takes from you is the transaction handling. And I think this is also one of the most important things. You don't need to take care of transaction handling within any database service itself. It's taken care of in the base database service. The only thing that later on an actual database service must provide is a way to execute the CQN that is generated, or also for the begin and commit to actually happen on the database. If I try to summarize it in one sentence, it only thing that must be provided for the database service is a factory to create connections and destroy connections, a method for working with the session context, and something that we will show later on for executing the actual SQL statements. The SQL service extends the database service, and this is basically the main service that does all the heavy lifting. So you can also see this already in the, if I scroll up in the initialization function, you can see we register a lot of handlers here. So we intercept all the CQNs that come in and then transform it into a SQL statement. As an example, we can start here with the onSelect function, just as a quick preview. It's two things I want to highlight here. First thing is it calls this CQN to SQL function. And if we quickly jump into it to see what it does, it's two steps. It does the normalization of the incoming CQN that Patrice has already shown us before. The beautiful, nice, comprehensive CQN is transformed to a big join or whatever you have specified. And this CQN is then put into our CQN to SQL translator who creates the SQL string. The output also Patrice has already shown us, but I would like to quickly jump into this class to show or continue the example of the select statement. A little bit further here. How this class basically works, it interprets all the known CQN properties. You can see the deconstruction in the first line. It takes all the known properties and calls the respective functions of its class. For example, you have for from, where, clause, group by, you have respective functions. This has the huge advantage that when we now implement really a Postgres service or any other SQL database, we can simply extend this class to plug in our own logic. I will show this also in a minute for the Postgres service, but this gives the flexibility that the base implementation that we deliver out of the box can be changed for each CQN property. So if there's something special for a database or for your use case, you can extend it and customize it to your needs. Jumping back to the SQL service to continue what happens here. After the CQN to SQL function, I jump back to the onSelect. We call this prepare, and this is the only thing that one needs to be needs to provide for the SQL execution. If we jump back here, we have an interface for the prepared statement that a subclass would need to implement. In addition, we also need a function for executing plain SQL statements directly. But this is the only two things that a database service needs to implement. So if we consider the database service, connection handling, session context, and we need plain SQL execution and a prepared statement. So basically 4 functions that are to be implemented by an actual database service. I now jump to the Postgres implementation. We can recognize we have the factory for creating and destroying connections. First function that was to be implemented. We have the set function, now collapsed, for implementing the session context. And we have number 3 and 4, prepared statement execution. And 4th function, plain SQL execution. And those interact with the database drivers, and this is what we expect that actual database service would need to implement if everything would be ANSI SQL, which is of course not. Coming now to the extensions. So I have shown that that a database service can extend the CQN to SQL function. This is it's here. This is also what our Postgres service does. For example, it customizes ordering, because ordering is often database specific. And if I now scroll to a more an easy to understand example for Postgres, you can see we have the value. Value is basically the CQN property that ends up in a placeholder in a prepared statement. And what we do here is we replace the question marks that we typically know from HANA or SQLite. We replace it to the Postgres variant, and Postgres wants to have numbered dollar identifiers. So we create $1, $2 instead of the question marks. With this technique, you can basically customize any of the CQN parsing to SQL. And with this, I'm already at the end of my presentation. This was kind of a very quick introduction into the concepts. I now need to add a disclaimer. The APIs are not yet final, so we are still in the discussion how the API and interface exactly has to look like. So please treat this as kind of a sneak preview of how it's designed to be. The concept should stay, but the APIs are not yet final and also not yet documented. That's it from my side. Thanks.
Okay, thank you, Johannes and Patrice. Are there questions in the room online there is this big discussion, including code samples, going on about updating the beer shop, and I'm probably the only one in the room who doesn't know what this is about.
Yes. So I was kind of involved into the former open source PG project, and I'm kind of dug into the core of stuff. And seeing you guys really did a great job on bringing this together in a very nice way now. So big thumbs up from my side. Okay, I just have one specific question. So you showed a lot of tag string literals to actually define the queries against the database, which looks pretty nice. And, but do they work with like auto completion, or is there, because
So yeah, thanks for the question. I'm afraid if you use the template string syntax as I did, you won't get nice code completion as if you would write your queries with the Fluent APIs. However, I just like to do it like this because I have a compiler background, and this is how you would define a static query as well, right? So
yeah, there's some supporting VS Code for this tag template strings, which allows you to define that something prefixed by CQL is another language. GraphQL guys do that. The Apollo frameworks, they do that. So it seems to work. And in that, we can then plug in our standard CDS things. Yeah,
thank you, Daniel.
More questions here? Yep. Comment?
Help with the beer shop. So actually, like the test bed for the former implementation was the PG beer shop, which we then made to be deployed on the Cloud Foundry environment of BTP, but also on Azure. I think we had several places where we were able to deploy, and that is not yet updated. I hope I can use the train ride tomorrow to bring it up to speed. So we have a sample for full deployments and also to BTP Cloud Foundry.
Any more questions? Maybe we can have, I don't know, what time is it? One more, two more? Okay. 1, 2, or who was first? Do you know? You're better reachable.
You showed that nice multiple select with one select with the JSON syntax. Did you do some kind of performance testing with HANA execution plans and stuff like that?
Yeah, actually we did. I don't have the concrete numbers now. Maybe Daniel, you can add to that.
Yeah, we did some tests. Bob, who was doing this JSON function things very initially, brought some very, very impressive numbers, but we have to validate these. What I tested is S-Flight with the former SQLite layer. And you know, when OData sends a request, that usually has a lot of expands for all the tiny little value helps, because OData can't do path expressions. They only have expands. And with the old driver, SQLite driver, it was 200 milliseconds, and with the new one, it was 20 milliseconds. And with SQLite in memory, there was no network round trip. So we expect even higher numbers when we see the HANA round trips.
Maybe to add, we had a look with Oliver, your colleague, to the performance of some of the expand requests within your project, and we also observed that they were faster than before. Only thing that we have seen is that the CPU consumption on HANA slightly increased. So it has to do a little bit more, of course. But we assume that pushing this down to the database should eventually lead to a better performance.
Sounds good. And here's one more question, and then we'll call it a day, I suggest, so we have a bit of break.
Does this new PG adapter support multi-tenancy?
Not yet, but we are working on it. Daniel just said it supports it itself, but not yet included in the MTX module.
All right. Then let's leave it at that. Thanks again.